Thank you, Dr. Shaw, for your sharing. Also, we would like to invite all the participants to enter our lucky draw to receive the gifts sponsored by Microsoft, Red Hat, and JetBrain. Just simply fill in the online survey form during this 2 days event. The survey link is shown at our online virtual lobby, which all of you should receive the link by email to our online conference room already. Please refer to the guideline there to fill in the survey. The winner will be announced on June 19 in the Facebook fan page.
Next, I'd like to introduce our next kernel session that will be brought to you by Mr. Rada Loy from Red Hat. The topic is Emergency Response Demo, the Power of Communities. It clarifies how the accelerating pace of open source innovation can be harnessed today on a microservice event-driven architecture using the product that comprise Red Hat's unified application environment.
Our speaker, Mr. Radio Loy, is a senior solution architect in Red Hat Hong Kong who specializes in Java electronic engineering application development and system integration on various industries, including finance, telecom, and government.
Red Hat Hong Kong is a company focused on the application development product, including JBoss middleware and the cloud application platform OpenShift. Red Hat is also a sponsor this year, and the conference kindly sponsored by them. Thank you, Red Hat, for your support. Now, let's welcome Mr. Loy onto the stage to share his insight. Mr. Loy, please.
Okay, thank you for the introduction. So let me introduce myself first. I'm Wei Loy. So today my topic is emergency response demo, the power of communities. The reason why I choose this topic is because the main theme of this demo is about power of communities. Yes, so let's continue because some situation here. For this demo, because the main theme is the power of communities. So I think this is quite matched with this open source conference, because the open source communities is can be contributed by the whole developer communities the developer, if they want to contribute their source code to help building better software, they can contribute their source code to the community. So that's why I choose this topic. And this is the first time I present in this open source conference, so I'm very excited that I can present and show the demo time. Okay, so we are preparing. So we wait for a moment. Let's continue because sorry for some technical issues. And okay, so I think you guys can see my slides. And sorry for some technical problems, so the slides cannot be projected full screen. And this is my session's agenda. So I will talk about what is this demo about, and the architecture of this demo, and then it is the real demo time. And this demo is actually very interesting because it is an interactive demo, so that all the audience can actually participate in this demo. Like you participate in the community projects, you can contribute to this demo. And it's a lucky that all of you guys cannot join this demo together in this venue because of some special situation. But we can all of you can still join from your mobile or computer at your home, at your office remotely. So okay, let's talk about some details of this demo. So this demo is showing the art of the possible when communities come together. Just like the community open source project, everyone can contribute their source code. And this was inspired by an incident that happened in 2017 in a place called Wilmington in the United States, and it was inspired by the Cajun Navy. Cajun Navy actually is a volunteer group who have a private boat, so that when there's a typhoon or a hurricane that happen in that situation, then the Cajun Navy can use their boats to rescue other people to save life. So this demo is this is the background of this demo. And this demo also showcases how to use the open source software to build an event-driven microservice architecture. Because in this demo, we will use all the software we use are all open source. And this is a modernized architecture that can support microservice and then hybrid cloud architecture. Okay, so let's see some high-level overview of the components in this demo, and also the technology used in this demo. In this demo, we use a technology like container, so that we can easily scale out, and also we can make use of the microservice architecture to build this demo, and also we can deploy this demo in a hybrid cloud environment. And also we have some one-time framework that so that we can use the one-time framework to run different kind of microservice framework to run those microservices and API. And also we also use the integration technology, so that our service can integrate other third-party systems or external systems to retrieve some external data, like the map data or the weather data. And also you can see that we also use the technology like process automation, which is also called BPM, and also decision manager, which is the rule engine to help to do some automation on this application, like automate the process flow, and also automate the matching between the incidents and responders. And on the left side, you can see that we have some monitoring capability, and also right side we have used some development tools to help develop this application quickly. Okay, so in this diagram you can see that this application is run on the platform called RHMI. RHMI stands for Red Hat Managed Integration, which is a platform that runs on OpenShift. And on top of OpenShift, in the RHMI, we also have different integration component and event components, such as the Kafka to store those events and trigger different microservices. And also, on top of that, you can see that we have a different microservice component to help to run this application. So the first one is an incident microservices that help to manage different incidents in this application. Incident is the definition here is when a people is stuck in his house because of the flooding, then they maybe call for help. Then we call this one an incident. And after this incident, and this will trigger a process flow to automate the whole process. So you can see that we have a process microservices here, and all the volunteers that have a boat that want to rescue people, then those are called responders. So also we have a microservice called responders to manage these responders. And after the assignment of the responders to this incidents, then we create some instance called missions. And so that's why you can also see there is another microservice called mission to manage this data. And all of these microservices will expose as API, either an external API, internal API, or third-party API. And we also have an SSO component, single sign component here to manage the responder registration, and also the responder authentication using the OAuth protocol. And on top of it, we have a web-based console, and you will see later in the demo how this console can monitor the whole situation through a web-based Node.js framework. And you can see that this is a screen capture of the emergency console, which you will also see later on through the demo. And using this console, you can monitor the whole situation through the map, through a web map, and also the real status of all the responders and all the incidents. And this is the flow of events. So the flow started by some incidents. Either it is called by an external API or using a component called disaster simulator to simulate the incident. And after that, this incident event will trigger the whole process flow, so that it will start the BPM process and to control the whole process flow. And after that, some responders, those volunteers, can register themselves and say that they are available to help in this situation. Then they will generate event and then also put in our event messaging infrastructure, Kafka. And this event will update the process flow, and also we have a rule engine to match, to do a matching to see which responder is can be assigned to which instance, so that they can help on those instances and create a mission for them, so that they can drive their boats towards the incident and pick up people and then take them to the shelters. So this is a simple overview of the flow. And in this application, we use a container platform which is OpenShift, so that you can deploy it on hybrid cloud, either on premises or even on different public cloud. And then on top of it, we have application runtime for running different microservices framework. We have connectors to connect different external systems. We have enterprise integration pattern, which is camel routes, so that you can define different integration logic for this EIP. And also we have an API designer, so that you can design the API and also manage the API. And the messaging, we have Kafka to do the messaging. And we also have a mobile framework to define the mobile front end. And on top, we also have sign-on and derivative rules to do the application development. Okay, so to map with those web headquarters, and all of these are open source software that's supported by Red Hat. You can see that OpenShift is here, and also AMQ Online is our messaging product that both contains the AMQ Booker, JMX Book, the traditional JMS Booker, and also the AMQ Stream, which is the Kafka. And you can see also fields and other components that help to build this application. For the API management, we have the fee scale to act as an API gateway, and also to manage how the APIs in the backend. And you can see that there is a code ready here, which is a web-based IDE, so that we can easily to write a source code for a web-based IDE. Just open your browser, and then you can write source code there. Okay, so here are the different components in this view. So you can see that we use different language, different frameworks, and the different components that work together, like in a what we call event-driven microservices architecture. So for the consumer, which is a disaster simulator front end, which is using Vertex. And Vertex is a reactive framework that help you to do reactive programming, so that you can write an application that can support large concurrency, so that even your application is very popular, then many traffic come in, you can still handle the large traffic. And we also have a console that is written in Node.js, like what I said before, the Node.js web console to monitor the whole situation. And you can see fee scale here for the API management, and for different microservices all are already exposed as RESTful API, and they are implemented with different microservice framework. Some are using Vertex, some are using the I think the most common microservice framework now is Spring Boot, and also we have fields to integrate external system to retrieve the weather data. And in the backend, you can see we use the JBoss data grid as the data caching framework, so that the data retrieve or data update can be much faster using the cache framework. And we have AMQ stream, which is the Kafka for storing the event. And we also have the PAM, which is the BPM for doing the process flow, and also Prometheus of monitoring. So I think I am run out of time, so maybe I should start the demo right now. So this demo, like what I said before, it is interactive and everyone can be participate. So I will show an URL so that you can, all of you can join with the this URL with your mobile or computer to participate in this demo. Okay, so it's demo time. Let me open the browser here. Okay, so here is my emergency console, and you can see that there's a map which shows the location for called Wilmington, and then in this location there will be some incident, because I will generate some simulate some incidents, and every one of you can add as a responder. So how to add as a responder? So I will show you first how to register as a responder, and I will show the URL later on. So I will first do once myself, so then you can follow. Once you click on the URL that I will show you later on, then you can see this screen, and then you can register a new user so that you can be a responder that participate in this demo. So you can click register now, and then fill in your information. Just fill in anything. So email, you can still use any kind of email, and phone number, anything. And then this number is the boat capacity, because some incidents may have more than one people, so that you may need to have a large capacity in order to can rescue all the people in this incident. So maybe use input 10 here. And for this option is about whether you can provide medical support, because in some incidents, some people may be injured, so you may need to provide medical support. And then username, just type in any username here. Okay, password, anything. Okay, so click register. Then now you can participate in this demo. So and you can see that you can ignore this alert warning, and then after you click on the map, then you define your location. And the next thing you have to do is to click available, so that the system can know that you are available to start the rescue. Okay, so after that, I will open the console here. I will log in as an incident commander here. Okay, so you can see my emergency console here. There are already 2 total responders, because one I already registered before. And then now what I have to do is to generate some incidents. For example, I generate like 50 instances. Okay, I only have 5 minutes. I have to hurry up. Okay, so when I generate this instance, and then you see that in my emergency console, the number of incidents is increasing. And then because I have clicked on the available button, so that the on the backend side, the incident will first trigger a process, a business process, and then also trigger the rule engine to find whether there are responders that can match this incident that can help to rescue people for a mission. So you can see these are the responders that already registered to this system. And I think now of you, if you want to join, so you just click on type this URL to your browser for either mobile or your computer, so you can join this demo. So the URL is tinyurl.com/hker-demo, and then after you register, and you can then I can see your icon here, so that there will be mission assigned to you to help to do the rescue. Okay, so while we are waiting for the responders, so you can see that after there is mission assigned to you, you will see a screen in your browser that there are two routes. One route is your boat to drive to the incidents to pick up the person or people that who need help. And after your boat drive close to the incident location, then you can see that there is a pickup button that highlight here that for you to update your status. So whenever you update your status pickup, then the boats move again, which pick up the people and then take them to the shelter. And you can see the boat is moving through the blue route to deliver the people to the shelter here. And on my emergency console, I can also click on the incidents and see that the update status for a BPM here. So when I click on the process image, I can see that what is the latest status of my process. You can see those gray color boxes are all the steps or procedure that already finished, and now the status is here. It is called pickup, and then so that you can see that for this mission, the rescue is already picked up by the responders and are taken to the shelter, so that you can see clearly what is the status of each process for this view. Okay, so come back to our emergency console. It's very good that we have increasing number of total responders. And when click on the responders, you can see the name. Like let's see, this is MT10. Very good. And so that it's very interesting if there are many people participating in this demo. Let's see, this one is called Well Hello. Okay, very good. Okay, so the number of responders is increasing, and I think all of them are enjoying to participate in this demo. So that's the reason why I want to choose this one. Is this is fun that everyone can be participate, like the open source communities. Every volunteer, if they want to help building better software, they can participate anytime by contributing source code, like this demo. If they want to help to rescue people, they can do it anytime by just pick up their phone and then register they are available to help, and so that then the system can assign them to different mission, and then they can follow the what the system assign, and then to rescue different people. So, and also this demo demonstrate like how a microservice architecture can be deployed on OpenShift and on our RHMI Warehouse Management Integration Platform. And you can see that actually in the backend there are many microservices running to support this kind of application. All of them are built using open source software and supported by Red Hat. You can see there are data grid service, there is a Kafka cluster, and also there is a PostgreSQL and a process service, which is called the BPM and the Blue Engine to do those different kind of automation. And for this kind of microservices, every microservice can be individually scaled. So whenever the resource for that microservice is high, then it can be easily scaled up by just doing even auto scale, setting auto scale in this OpenShift platform. Okay, so I think my time is up, and I think, but I can still leave the demo here. So everyone, if you want to join this demo, want to pay with this demo, you can still go to this URL, tinyurl.com/hkel demo, and then continue to pay with this demo. So that's all of my session. So thank you all. Sorry for those technical issues, and hope you enjoy this session and enjoy this demo. Thank you.
Thank you, Mr. Lord, for such a great speech. Thank you. That was indeed an informative sharing. Following the trends of developing AI, the discussion about whether AI is an angel or a devil has been brought to the table. However, the real question is how we all can build technology design